I'm Timmy Calder, an applied mathematician, and this is Unlocking LaTeX Graphics. On this channel, I present tutorials on using TikZ and PGF plots. Today, I'll talk about using TikZ to draw on top of an existing image or figure. In the example I'll show today, I'll illustrate how to draw on top of a 3D graphic that I created in MATLAB. This is an example from an appendix to the textbook that I co-authored called 10 3D Compositions for Data Science. I'll link to that book in the comments. This example is from the world of optimization, where I want to add pointers to indicate global and local extrema, as well as saddle points. This example illustrates TikZ concepts such as nodes, grids, relative positioning, arrows, and edges. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Before we get started, let's set up our LaTeX document. We'll use the standard article document class. I load hyperref to link the author name to the YouTube channels you see over here. The graphics package provides the include graphics command, which will need to include the image that we'll be drawing on top of. Of course, the important package is TikZ, which we'll be using to create our graphics. We will also include the TikZ libraries for positioning and arrows.meta, which gives us arrowheads, and we'll need both of those later. The first thing I'll do is create a figure environment with a TikZ picture inside. I have just a single node that I'm drawing the outside of. I'm setting the inner separation to 0, so there's no extra padding around the image. I'll add a link to some relevant episodes about nodes in the show notes. Inside the node, I have the include graphics command to include my image. In this case, the file is named optfunc.pdf. I set its width to 5 inches. I'm drawing the outline of the node in red so we can see its boundaries. I explicitly set the node inner separation to 0 pt, so there is no extra padding around the figure. What we can see is that there is some extra white space around the image, which often happens when exporting graphics from other programs. The way to get rid of this extra white space is to use the trim and clip options of include graphics. So I'm going to put it inside the options for include graphics, and I'm going to paste it right after setting the width. So I'm going to set the trim to start off with to just 0, 0, 0, 0. It takes 4 parameters, left, bottom, right, and top. So I'm starting with no trimming at all. And the clip option tells LaTeX to actually apply the trimming as opposed to just resetting the bounding box. So it'll just cut off that extra space. It usually takes a little bit of trial and error to get the trim values right. So first, let's trim a bit from the top, which is the 4th value. So I'll start off with a trim of 100. And when I click that, I see that it's actually cut off more of the top than I would like. So I'll try again, and I'll just do 50. As it turns out, the second time is the charm for this one. 50 is almost perfect. It's right at the top of the image. You could go and play with that some more, but I'll just use 50 here. I'll go ahead and take the same value from the bottom, and this turned out to be the perfect amount for the bottom as well. So that looks perfect. I could also trim from the sides, but that will affect my width. So if I trim from the sides, the whole image will be larger. And I actually don't want that to happen. I like the size that it is, and that's not really hurting anything. So I'm just going to keep that as is. And now I'd have my image the size that I want it to be. I'm going to remove draw equals red from outlining the node. So now we just have this image that we're going to draw on top of. Now that we have the image looking good, let's add some TikZ elements on top of it. We need to determine the TikZ coordinate of the points we want to highlight on the image. One way to do this is to add a temporary TikZ grid on top of the image so that we can read off the coordinate. Inside this figure, after the node for the image, I'm going to go ahead and create a brown grid with default lines every 1 unit in the X and Y directions. I'm going to go from the range -3, -4 to 3, 4. And I'll add a link to the TikZ grids episode in the show notes. I added a small node at the origin to mark 0, 0, just in case that wasn't clear. This is the center because the image node we created above is centered at the origin by default. Before I go any further, I'm going to add a style up top that defines a point of interest. So I'm going to be adding points of interest to my image. And so I'm defining a style called POI. It creates a small filled red circle to mark a point of interest. I'll add a link to an episode on named node styles in the show notes. This coloring I'm doing right now is filling it in with red. It's just for placing the nodes. I'm actually going to make them invisible later on once we have everything set up. Now let's mark some points in our diagram. First, I'll add a point at the global maximum, which is this yellow peak up here. In the TikZ coordinate system, according to our grid, this point is at approximately minus 1.5, going over about 1.5, and up 1, 2, 3, I think 3.75. So that's what I use right here. And we'll go ahead and compile that and see where our node ends up. It's not quite where I want it to be. So then I would play around with this minus 1.5 and 3.75, making small adjustments until I get it where I want. It turns out that where I want is minus 1.62 and 3.86. And when I compile that, it is now at this global maximum, which is what I wanted. I repeat this process of trial and error for all the points of interest, which is the local maximum, the global and local minima, various saddle points, and an intermediate point. So let me just go ahead and paste all my points here and compile it, and you can see that I now have all these important points. I now have them located in the TikZ coordinate system. Now that I have all the points placed, I can remove the grid and the origin marker since we no longer need them. So let me go over here and I'll just comment out those lines. Next, we'll add 2 more styles for the labels up here above. So I'm going to add a style for a label for a point of interest, which I'll call POI label. And then I'll add a style for the edge, which I'll call POI edge. The POI label style makes the font footnote size and reduces the inner padding around the label text. The POI edge style defines an arrow style with the LaTeX arrowhead that comes from the arrows.meta library. I've also set the length and the width of the arrowhead to 1 millimeter each for a nice appearance. I'll include links to episodes on arrows and on edges in the show notes. Now I'm ready to add some labels and arrows to the points of interest that I created. I'll start with the points in the top half. So I'm adding 3 different labels here. I'm adding one pointing to the global max. This is here. One pointing to a local max here, and one pointing to a saddle point. The nodes have the POI label style, and I'm placing them above the respective points of interest using the TikZ positioning library. So that's where this above equals, and then I give the distance, and then of, and the name of the node that I want it to be above. I'll include a link to the positioning library episode in the show notes. Next, I'll add a couple more labels. This time, I'm not using the positioning library because I want more flexibility in where I paste the nodes. In these cases, I start at the point of interest, and then I do a move to operation to move relative to that point to get where I want the label to go. So, for example, from this lower saddle point, I move minus 0.2 in the X direction and minus 0.9 in the Y direction. Then I create a label node at that new position and then draw an edge back to the point of interest. Lastly, I'll add labels for the minima at the bottom of the figure. For these, I'll use the bend option to make the arrows curve nicely to the points of interest. And here's the result of that. Now that all the points of interest are labeled, I'll set to fill to none in the POI label style up here, and those red dots will disappear. So this is just a style preference. I don't want those red dots to be there. Now I've completed the augmentations to our image. I really like adding on to images in this way using TikZ. One caveat to keep in mind is the following. If you resize or change the trim of the image, the coordinates of the points of interest will no longer be correct. So be sure to finalize the image size before adding your TikZ overlays. Notice how I placed these points of interest and gave them names so that in case I do change the image size in some way later, I can just change those 7 points and nothing else in the image really needs to change. I hope you enjoyed today's episode on drawing on top of images using TikZ. If there's interest, I'll create a follow-up video showing how to add axes to a contour plot image. PDF plots is not especially well suited for contour plot, even though technically it does it. So one often ends up creating the graphic itself in another program. We can still add labels, axes, and even color bars using PDF plots and TikZ overlays on the contour graphic. I put a link to the overlay document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. If you have TikZ or PDF plots questions, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.